Welcome to IBLE Math, where we teach IB Maths for students by students. In today's video, we will see some of the basic background knowledge that every single student should have before starting with the IB Math AA course. Now, if you're considering taking this course, you should be really comfortable with the concepts and with the examples that will be mentioned in this video, and you should be able to solve everything without any sort of problem. Now, the first example, the first thing that every single student considering taking the course should be able to solve are simple algebraic equations like the one on the screen. Now, this is something that is taught from the beginning of high school, and it's something that really should not be a problem to any of you. In case you find this too basic, you can skip this part of the video and continue with the next examples. Okay, so in order to solve this, we have to first of all simplify both sides of the equation. I didn't mention it, but they are asking us to solve 4x, which can be found here and here. Okay, so some of you might have already noticed that the right-hand side is already simplified. The right-hand side of the equation. This is the left-hand side, this is the right-hand side. Now the right-hand side is already simplified. We cannot do anything else with it. But the left-hand side has still some work to do with it. Now, what we're going to do now is to first of all expand the brackets. Now, most of you should all be already familiar with this idea. Anything that's in front of a bracket and is multiplying those brackets. If we've got this 3 in front, so if we've got this 3, this should multiply everything that's inside the brackets. Now, these two things. Now, so if we rewrite this this equation in a more simplified way, we will get 3 times 2x over 3. Now, this is maybe not so simple at the beginning, but you'll see how this will simplify. Plus 8 times 3 equals 12 plus x. Again, as mentioned, the right-hand side doesn't need to be changed. Now let's solve this bracket. Now, we see here we've got a 3 and a 3. One is in the denominator and the other one in the denominator. You should know that this is the same as 3 over 1. And therefore, if we've got one number in the denominator and then the same number in the numerator, then they will cancel out. And they should be always multiplying, not in a sum. Then we don't change anything. But anyway, if we solve this, we'll get how these two numbers cancel out. Again, most of you will be already familiar with this, so we'll only get 2x. And then this will be plus 8 times 3, which is 24. And this will be equal to 12 plus x. Okay, so what we're going to do now is try to bring all the x's. By the way, this is a semicolon. This is not an I or anything. It's just in there to separate the equation. I should have already written this here. It's just to show how the equation is finished. So we've got x's here. So we've got 2x here, and then in the right-hand side of the equation, we've got a single x, and then we've got numbers here and more numbers here without any x. Now, what we should do is try to bring the x's to one side and then this independent numbers to the other side. So what we'll do now is we're going to bring this x to this side and the 24 to that side. Now, again, you should understand this, but what we're going to do is 2x, this will remain in the left-hand side, minus x, because we're bringing it from the other side, so it's subtracting, equals 12. And then this number, 24, this number in here, will go and we'll subtract, so it will be, 12 minus 24. So it's subtracting. And so if we simplify this, we would get x, because 2x minus x is simply x, equals minus 12. 12 minus 24 is minus 12. And this is the result that we would get. Again, you should be familiar with this. This is a very simple example, but that's something every single student should know before starting the course. Now, moving on to the next example, we're going to rationalize, I don't know if I said this right, rationalize, these fractions with square roots in the denominators. Now, this is also something that is taught throughout high school. You should all be familiar with this. And that's something that you will need to know before starting with Unit 1 of the IB Math AA course. So, this is our first example is going to be 7 over square root of 2. Now, the idea here is that we want to eliminate square roots from our denominator. Because they are generally, difficult to deal with, especially if we are using more than simply one fraction, if we're summing fractions, or we're adding fractions or multiplying fractions. That's something we should avoid, having square roots in the denominators. So what we'll do is, in order to eliminate this square root, right, we will times the denominator. So we can rewrite this here. I'll write 7 over square root of 2. Now, in order to eliminate this, we can multiply it by square root of 2. But if we only multiplied the denominator by square root of 2, we would end up with a completely different fraction. So the thing is, if we multiply both the numerator and the denominator by square root of 2, we're in reality just multiplying it by 1, because the same number, one number divided by the same number will be equal to 1, right? So what we're doing here is simply making it easier. So this will end up with something like this: 7 times square root of 2 over square root of 2 times square root of 2, which is nothing else but square root of 2 squared, okay? And then this will be, the numerator will remain the same, 7 times square root of 2, and the denominator will simply be 2. Because remember, I just want to make a point here, this is the square root of 2 times square root of 2 is the same as square root of 2 squared. And whenever we've got something like this, these two cancel out. The power and the squared and the square root of 2, they cancel out. So this would be our final result, which is more or less the same. We could think, well, we've got more numbers than in this first example. Here we've only got the 7 and the square root of 2, and here we've got a 7, a square root of 2, and a 2. But in reality, you will see as you move through the course how this kind of examples will be easier, and how you should also always aim for such fractions. So this is something you should know. Now let's go to a perhaps more complicated example, but it's not something really difficult. Now this is 11 over square root of 3 plus 2. Let's solve this. Let's just write it again. Now, what we're going to do here is quite similar to what we've done before, okay? Now, we're going to do 11 over square root of 3 plus 2. Now notice, if I was to multiply all this times square root of 3, or let's say something like this, let's just write this example and see what would happen. Now, if we did this, we would get 11 square root of 3. We're multiplying the numerator and then the denominator also by 3. Square root of 3, sorry. So we would have square root of 3 times and then square root of 3 plus 2. Okay? You could say, okay, it's fine, but in the end, we would end up with something like this. Square root of 3, that's fine, but then, okay, we've got square root of 3 times square root of 3, which is simply 3, so we eliminated one of these roots, but then we'll get 2 times square root of 3. So plus 2 square root of 3. And we still have the same problem. We still haven't removed that square root from the bottom of the fraction. So let's say this is wrong. Let's indicate this. Wrong method. And then the right method would be to do what we're going to do now. Let's write it again. 11 over square root of 3 plus 2. And now we should multiply this by, so let's say, we'll just write this in brackets. We must multiply this by this same two numbers, but instead of them adding to each other, the two should be subtracting. So we should get something like square root of 3 minus 2. Okay, now you'll see now why this works. So we'll go a little bit more in depth, or we'll see some more examples in the next examples. I mean, we'll see some. You'll understand this better after some examples that we'll mention next. But the main idea of multiplying this is that I'm not going to expand all this. I'm not going to do this times this, plus this times this, plus this times this. I'm not going to do this because this is too long and it's not really efficient. Now, we should know also from high school that, first of all, let's write the denominator. So 11 times square root of 3 minus 2. We should know that the denominator, if we multiply the same two numbers, let's say, one of them having a plus sign between them and the other one having a minus sign, let's say it, let's keep it simple, let's just say that's what we've got, then what we're going to get from this is the first number squared minus the second number squared. Now, this would leave us then with the first number, which is square root of 3 squared. So square root of 3 squared is just 3, minus the second number squared, which is minus 2 squared. Okay. Now, just to make it clear, if we've got a plus b times a minus b, what we'll get is a squared minus b squared. Now, you can try it by yourself. You can try to expand this and see how you will end up getting this. Okay, so you should just know this, and you should have it constantly in mind. So what we'll get here is 11 times square root of 3. So 11 square root of 3, just like this. And then 11 times minus 2, which will be minus 22. And then all of this obviously divided by 3 minus 2 squared, which is 4. So 3 minus 4 will be equal to minus 1. And if we just want to completely finish this, we could just say 22 minus 11, 11 times square root of 3 over 1, or over nothing, just without anything. This would be our final result. Okay, now let's look at our next example of things that you should know before starting with the course. And these are this kind of fractions. Now, these are simple equations, we could say, but we've got some complicated things in our denominator, as you can see here. Now, it's perhaps something similar to what we've seen before. We don't want to have these complicated expressions together with square roots and all these things. We don't want to have this in our denominator, almost never, okay? So we just want to simplify this and solve for the value of x. Now, you could think, well, I could just bring this to this side multiplying, so this to here multiplying, and this to here multiplying, so we just multiply by these numbers on both sides. But that wouldn't work because we've got a plus sign between these two fractions. They are not the same fraction because they are not multiplying themselves. If you get what I mean. So what we have to do here is we need to get a single fraction. We've got two separate fractions. We just want one. And the way to do this is by getting a common denominator in both sides. So how do we do this? Well, let's see. Let's copy this same thing, leaving some space. You will see why. So I'm gonna write 3 over 2x plus 1. I'm gonna leave this with some space, and then plus 1, and I'll write 2x plus 8, and this will equal 6, which is what we've got right above. Now, we want to have the same denominator. So if I multiply this value here in the denominator by this other denominator, I will get 2x plus 1 times 2x plus 8. And if I do the same on the other side, but with the other denominator, I would get 2x plus 8 times 2x plus 1. And notice how now I've got the same denominator on both sides, right? Now, I just cannot write here whatever I want in the denominator. I've just completely changed the equation. So in order to balance this, we'll do something similar to what we've done before. We'll just multiply the numerator but by the same value. So in this case, we're going to multiply it by 2x plus 8. So we've got the same on this on the numerator and denominator. And on the other side, since we multiplied times 2x plus 1, we'll also times it here. Okay, so time to solve now. I'm going to write a semicolon here. And we see how we get 6x plus 24. We just have to expand this over. Now, for now, I'm just going to leave it like this. So 2x plus 1 times 2x plus 8. And then plus 1 times this will just be 2x plus 1 over, and let's just write this here. It's quite simple. As you can see, it's not that difficult. Again, you should already be familiar with this, but in case you're not, you can see how it's not that difficult. And this will be equal to 6. Let's separate this. Now, as mentioned, both sides have got the same denominator. So if we've got two fractions with common denominator, we can just sum them. we can just add them, sorry. So I'm going to leave a common denominator for both. So that will be 2x plus 1 times 2x plus 8. That's what both of them have. And then I'll just sum these two fractions. Remember this, there's a sum sign here, or an add sign, and we're going to add the two numerators together. So we'll get 8x plus 25. And remember, all of this is equal to 6. Okay, we're getting closer to the final value. So what we'll do now is we'll bring this to the other side, both of them, because they are multiplying each other. So we'll just bring them to the other side. So what we'll have left is this. We should have something like this, equals 6 times 2x plus 1 times 2x plus 8. Again, really simple. And we'll continue. We'll separate this, and we'll get in this side exactly the same. 25 equals. And now let's see, because okay, first of all we have to multiply 2x times 2x, which will give us 4x squared. Then we just have to multiply 2x times 8, which will give us 16. 1 times 2x, which is going to be 2x, and 1 times 8, which is going to be 8. Okay, so we'll get 8x plus 25 equals 24. X squared. I'm just multiplying this by every single number inside the brackets, because it's in front of the brackets and it's multiplying it. So it's going to be 6 times 4x squared, which is 24x squared, 6 times 16, which is 96, 6 times 2x, which is going to be 12x, and 6 times 8, which is going to be 48. Okay, so we'll get 8x plus 25, the left hand side is not changing, plus 24x squared, that's also not changing. Oh, I forgot to write an x here. Then 24x squared plus, we've got two single numbers here, so we're going to sum them, and they are going to be equal to 144, adding them together, then plus 12x. And if we move all of it to one side, so we'll bring these two values to the other side to just have a quadratic equation, we'll get 24x squared. Now the 8x will move to this side, so it will be 12x minus 8x, so we'll get plus 4x. And then this 25 will move to the other side, subtracting, so we'll get 119. And this will equal 0. And from here, we can just solve this quadratic equation, which is something you should also know how to do, which I'm not going to cover here because it's something basic. What we've seen before is also basic, but it's just something that you could even use a calculator in order to solve this. It's not a big deal. Now, our last example. The last thing you should know before starting the course is knowing how to expand these things. Okay. Now, if we've got x plus 2 squared, we should know there's a rule for this. We've got, let's call this a plus b. Okay. squared. This is the same with different numbers or different letters. We'll call this, instead of x plus 2, a plus b squared. And this rule tells us that what we'll get is a squared plus b squared plus 2ab. Now, you can see you could just write this as a plus b times a plus b and solve it. You could see how you end up with something like this. Well, with exactly this value. So knowing this, we'll just solve with this for this for x in this specific example. We'll just expand, not solve for x. What am I saying? So we'll expand this, and we'll get the first number squared, so x squared, plus the second number squared, or the second, not going to call it number, but the second, yeah, in this case it's a 2. I mean it's a number, so we'll call it simply a number, so x squared plus 4, and then we'll add 2 times the first one times the second one. So what does this mean? 2 times x times 2. And we'll just write this in brackets. And so what we'll get is x squared plus 4x plus 4. And that's what we want to get. And that's simply a quadratic equation if we equaled it to whatever, to 0, for instance. Something similar to what we've seen above. Now for this one, it's a bit different because we've got these two numbers inside the brackets. One of them, we've got some x's, let's call it x's, what we've got, and then we've got some independent values, independent numbers. So they are subtracting each other. So what we should know is that in case we've got this negative sign instead of a positive, we should know that this is going to be equal to a squared plus b squared. Again, this is just, in the example, this is just a, and this is b, minus 2ab. So this is not going to be plus 2ab, but minus 2ab. And so what we will get from here is 2x squared, which is going to be 4x squared. Then plus 1, because it's just b squared, which is 1 squared, which is 1. And then minus 2 times 2x times 1. Now, not times minus 1. This is b, this is a. b is not minus 1, it's simply 1. Forget about what's in the middle, okay? So we'll get 4x squared plus 1 minus 4x. And this is what we'll get. And this is, again, something similar to what we've seen above. But instead of having a plus 4, we've got a minus 4x. And for our last example, we've got something similar to this, but instead we cannot square one of these because they are not exactly the same. One of them is an x plus 3, so we've got both of them are positive values, and for the second one we've got one is positive, the other one is negative. So how do we solve this? Now, I mentioned before that if we've got something similar to this, I mentioned it when rationalizing, we should know that in these cases, the result will just be equal to a squared minus b squared, with this being a and this being b. Again, forget about this signs. Okay, so what do we get then? Well, we've got a squared, which is simply x squared. That's a big X. And then minus b squared, which is minus 3 squared. So minus 3 squared is 9. and this is what we would get. Okay, so that's it. That's everything you should know prior to the start of the course. If you like the video, don't forget to subscribe, give it also a like, and be sure to stay tuned